It begins as a gentle spring-fed brook, meandering southward through the Michigan countryside for 20 miles, until quite close to it, it widens into a river. The French voyageurs who called it La Rivière Rouge, the Red River, despaired of its usefulness, even as a ship anchorage, and kept their vessels in the Detroit River. But Henry Ford, who was born and grew up near the Rouge, had other ideas. To be near its shimmering waters, he and Mrs. Ford chose this river site to build Fairlane, the home in which they lived to the end of their lives. Because of the river's potential as an industrial waterway, he purchased thousands of acres of land in what is now the city of Dearborn to build the crown jewel of American industry, the Ford Rouge Plant. The essence of his plan was the flow of materials, and the flow would begin in the river with a widened, deepened channel, so that Dearborn would have a waterway through the Detroit River and the Great Lakes to the sea lanes of the world. This is a unique industrial city, the only one in the world where production begins with raw iron ore and ends with completed automobiles. The Rouge covers more than 1,200 acres interlaced with miles of paved roads that carry all sorts of vehicles. 3 times a day, the Rouge undergoes an almost complete change in population. The working force numbers more than 40,000 men and women who drive to work in $50 million worth of automobiles. Has its own railroad with enough track to link Cleveland and Toledo. Its high line is perched 40 feet in the air. The Rouge also has its own medical center with a permanent staff of doctors and nurses, its own uniformed protection force, and modern fire department. Generators in the Rouge power plant can produce 100 million kilowatt hours a month, enough electric power to light all the homes in Cincinnati. More than 80 miles of conveyors are needed to feed its production lines. Shiploads of iron ore, coal, and limestone are brought from American and foreign mines. Nearly 5 million tons arrive in Ford's own vessels. The ships are unloaded by cranes into storage bins, which can hold more than 1.5 million tons. Coal contains too many impurities for direct use in the iron-making process, so it must be made into coke. The Rouge coke ovens, when fully loaded, are processing 3,850 tons of coal. The fire is quenched with water to prevent further burning of the coke. Iron, man's most useful metal, is made by smelting iron ore, coke, and limestone in 3 towering blast furnaces. The raw materials are carried to the top of each blast furnace in elevator cars known as skips. Tons of air mixed with gas combine with the coke in the furnace to produce intense heat and smelt the iron. The furnace is tapped. Molten iron flows through a trough to an opening in the floor. Samples of the iron are taken to the laboratory for analysis. The molten iron pours down into torpedo-shaped vessels on rail carriages. This car is actually a mammoth thermos jug to keep the iron hot while it is being transported. 10 open hearth furnaces in the Rouge convert the molten iron into tough, versatile steel. First, a charge of scrap steel is fed into the furnace. This furnace has a capacity of 200 tons. Limestone is added. This acts as a flux and purifier and helps to remove phosphorus and carbon from the iron. Finally, molten iron from the blast furnace is added, and its conversion to steel begins. Aided by a new oxygen process, the steel is ready to be tapped in 4 hours. A charge of dynamite is installed in the tap hole. As the molten steel pours into the 185-ton ladle, bags of alloy materials are added. The impurities, which rise to the surface in the form of slag, are drained off. When the ladle is full, a giant crane moves it to the ingot molds. The new steel is poured into the molds. It is then allowed to cool and harden. After being reheated in soaking pits for 4 to 6 hours, the steel is ready for conversion into forms and sizes suitable for the making of automobiles. This ingot weighs 5½ tons. The ingots begin to change shape as they pass back and forth in the blooming mill. After 17 to 25 passes, the ingots become chunky slabs like this, or long rectangular blooms like this. This slab is sheared like a stick of butter. The slab is reheated and passed through hot strip mills. Tons of water cool the strip. Then it is coiled. The coils are now welded together to form a continuous strip weighing up to 30,000 pounds. The strip passes through a pickling bath of diluted sulfuric acid, which cleans the surface of the steel. After additional cold rolling, the steel is coiled and cut into sheets. The blooms, which we saw earlier, are converted into bar stock. A giant billet transfer table feeds the blooms to billet mills and merchant mills. A mighty squeezing process turns out flat bars for auto springs. How do the bodybuilders go about the task of making hundreds of thousands of door panels all exactly alike? The answer is here. The sheets are stamped on gigantic die presses, which have foundations that go all the way down to bedrock. The metal is squeezed between two matching dies, which have been shaped to the contours they now reproduce. A plaster model of a door panel must be reproduced in steel. The die makers literally carve it out of a massive casting. The white markings indicate areas where large amounts of metal must be cut away. Perhaps you've seen an artist using a pantograph. By tracing the original here, a duplicate drawing is produced here. The same principle is used by a profiling machine in the die shop. At the top of the machine, a tracing head moves slowly over the three-dimensional surface of the plaster model. And a cutting head faithfully follows the pattern to form the same contours in steel. The die produced by the profiling machine is moved to another area for grinding and hand finishing. The entire body shell is produced by die stamping more than 400 parts. Some intricate shapes are produced in a series of operations. To make a wheel housing, the stamping is trimmed and cut in half. The two sections are welded together. In the two foundries at the Rouge, one of which is the world's largest, automobile parts are made by pouring iron into sand molds. For the multiple casting of camshafts, shell molds are made of sand and resin. The mold is assembled, buried in a bed of steel shot, and filled with iron. The multiple casting emerges from the shakeout, partially covered with the mold material. Hammer blows knock off the gates and risers, leaving only the rough camshafts. They are then cleaned, after which they are inspected and straightened. The shafts are then sent to the engine plant for finishing. In the Dearborn foundry, engine blocks are produced by a complex process in which cores within molds are used to produce the intricate forms. As the block arrives in the engine plant from the foundry, the rough casting weighs 211 pounds. 46 pounds of this material must be machined away, some of it 1/1000th of an inch at a time. precise final honing of the cylinder walls completes the metalworking operation. During the process, the block has been subjected to a series of critical inspections. An air gauge makes certain that an invisible oil line inside the block has been properly formed. The blocks now move to the engine assembly line. Cylinder bores are inspected and graded with sensitive gauges. The bearings are put into place. These are comparable to the jewels in a watch. Pistons are installed quickly and deftly as the block moves on its way. The assembled engine now goes to the hot test stand where connections are made for coolant and exhaust and for fuel. Electric power is supplied to the starter and this is the fulfillment of the efforts of thousands of workers and suppliers who have helped to bring this engine into being. Ford is the only automobile maker to produce its own glass. Silica sand, limestone, dolomite, and other ingredients are laboratory tested, measured on automatic weighing machines, mixed and fed by conveyor to the glass furnace. The 2,700-degree heat melts the ingredients into a fiery lava. Samples are taken to the laboratory for inspection. The molten glass flows from the furnace between water-cooled rollers, forming a continuous solidified sheet. The newly formed glass passes through a 400-foot-long oven for controlled cooling. The 106-inch wide ribbon of glass is trimmed and cut into sheets. The rough windshield glass must now be ground and polished. The sheets of glass are mounted on a plaster base. They pass from one grinder to another, 30 in all, where moist sand is used as an abrasive to reduce the glass to the desired, more uniform thickness. The glass is transferred to the first of 50 polishers. The polishing gives the glass transparency. Revolving felt pads using a mixture of rouge and water polish the glass. The glass is turned over and the reverse side is ground and polished. The transparent plate glass is washed and inspected, and any area containing defects is quickly rejected. The glass is cut and trimmed on a template machine. Next, it must be curved. It is placed on a bending fixture. Then it is heated in an oven at nearly 1,200 degrees. The glass softens to the point where it sags by its own weight into the fixture. Cooled and re-hardened, it has the shape of a windshield. The curved pieces of glass go to the almost surgically clean White House, where they are to be made into laminated safety glass windshields. The pieces of glass are joined together with a tough layer of vinyl plastic in between. An oil-filled pressure cooker, known as an autoclave, subjects them to heat and pressure. This process turns the three layers into a single permanent transparent thickness of laminated safety glass. The longest assembly line in the Rouge is the one where bodies are built. The body shell begins to take form in a welding jig where side assemblies are joined to the roof. The body shell is moved to a second welding fixture where it is united with the floor or underbody. The frame, once a separate component, is an integral part of the unitized body. The welding continues in order to form a strong, quiet, friction-free structure. The welding job is finished and joints are brazed. Craftsmen fill the seams with solder, while others grind the welds and brazed joints to provide a smooth surface for the paint. The doors are installed and the deck lid is added. After a final check and smoothing of all metal surfaces, the unitized body is ready for its coat of color. The body is first coated with phosphate, followed by a double coat of prime paint and a trip through the drying oven. The primed surface is given a careful wet sanding to eliminate blemishes, and then comes the big moment in the paint spray booth. After baking for about an hour, the car emerges with a hard, high finish that will retain its beauty for years to come. The body continues down the line, receiving its weather stripping, glass, hardware, instrument cluster, and other items, followed by final inspection. Every car made at the Rouge is made to order, either for Mr. and Mrs. Customer or for the dealer's stock. The customer's choice of car, model, color, and other options is sent by teletype to final assembly in Dearborn. And the variety of choices is so great, it would be possible to produce cars all day at the Rouge without ever building two exactly alike. Final assembly begins with the front wheel suspension. The alignment must be perfect. A machine called the Octopus provides a means for quick, very accurate alignment. Meanwhile, on a nearby engine dress-up line, transmissions, fuel pumps, generators, starters, and other engine components are installed. another line, the rear axle and springs are assembled for attachment to the body. Here come the bodies. And now all the right parts and components, made and assembled in many locations, will arrive at just the right time for the right car, exactly as ordered by Mr. and Mrs. Customer. The completed car is given a careful visual inspection by an eagle-eyed inspector. And the miraculous moment comes when the world's newest automobile springs to life under its own power. The car is tested for headlamp and wheel alignment. The engine, transmission, instruments, brakes, and other parts of the car are given a thorough testing on the roll test machine. The operating components are performing beautifully. How about the body? The water is spraying at 100 gallons per minute, equivalent to driving at 90 miles an hour in a heavy rainstorm. But it's a sunny day in Dearborn. A brand new car, eager to go, is on the way to its new owners, built to order by the men, the women, the mills, and machines of this dynamic industrial city, the Rouge.